Alright, so today is our last video on talking about congruent triangles. We're now going to talk about how to go beyond corresponding parts of congruent triangles. So, what we mean by going beyond corresponding parts of congruent triangles is you're taking a pair of congruent angles or sides that you found by CPCTC, and you usually have to prove something else. For example, we're going to talk about how to prove we have a midpoint, how to prove lines are parallel, proving an angle bisector, etc. So the whole goal for this is pretty much you want to pretend for a second. If you want to prove you have a midpoint, you need to ask yourself, okay, which two sides would have to be congruent to make this a midpoint? That's the two sides you'd be looking for CPCTC. And once you say that, you can then say you have a midpoint because of your definition of midpoint theorem, stuff like that. So here's our first proof. So we're given this triangle. We're told that AC is congruent to BC. We're told that D is the midpoint of AB. And we want to prove that CD bisects angle ACB. So our goal is to prove that this is an angle bisector. We need to show that angle 1 and 2 are congruent. So with like all our proofs, we need to first prove we have two congruent triangles first, and then 1 and 2 would be our corresponding parts, and then therefore we have an angle bisector. So we have our givens first. Now let's use them. Well, if D is a midpoint, that means it splits AB into two equal segments, AD and DB. So AD is congruent to DB. That's our midpoint theorem. We also notice that CD is being shared by both triangles, so that's our reflexive side. CD is congruent to itself. Always look for that reflexive side. And now, I notice I have all three sides marked for the triangles, so I can say triangle ACD is congruent to triangle BCD. Got to make sure that you name them in correct order. ACD, congruent to triangle BCD. That's because of side, side, side. Well, we notice angles 1 and 2 are both opposite our double tick marks, meaning they are in the same spots. So I can say angle 1 is congruent to angle 2, not because of an angle bisector, because I don't have that yet, but because their corresponding parts of congruent triangles are congruent, our CPCTC. Since we now know the angles are both equal, that means CD has to be an angle bisector. CD bisects angle ACB, because that's what the definition of an angle bisector means. So for all these proofs, at the very least, even if you are completely lost on how to get to the proof statement right here, you want to prove the two triangles inside the figure are both congruent first. That takes up a majority of the proof. Once you have that, we can now say, well, we have our corresponding parts, and you'll know which ones to talk about is because look at your proof statements. We're proving an angle bisector. So which two angles would have to be equal if it was an angle bisector? That's 1 and 2. Okay, those are our corresponding parts. Therefore, we have an angle bisector. Let's take a look at another one. So we're given this triangle, this figure. So we're told that G is the midpoint of HF, and that EF is congruent to EH. We want to use all this to prove that angles 1 and 2 are both congruent. So again, we'll start with our given statement. And now let's use it. Again, G is a midpoint. As we saw last time, that means two segments are split evenly. So HG is congruent to GF. That's our midpoint theorem. We notice we have a reflexive side, EG. That means it's congruent to itself. It's reflexive. And then finally, since we have all three sides marked in the triangles, triangle HEG is congruent to triangle FEG. Also by side, side, side. Pretty much, I don't even want you looking at the proof statement until after you prove your triangles are congruent. If the proof statement is triangles are congruent, you're done. If it's talking about angles or sides, then look for what you need to do. Now, we're trying to prove angle 1 and 2 are the same. Now, 1 and 2 are not immediately equal because they are not inside the triangle, so they are not corresponding parts. However, 3 and 4 both are, and we notice angle 1 and 3 is a supplementary angle pair, so is angles 2 and 4. So I'm going to use that concept. Angle 3 is congruent to angle 4. Those are our corresponding parts of congruent triangles. And then I know that 1 and 3 are supplementary. And so are 2 and 4. That's our definition of supplementary angles. They're on the straight line. Now, a while back, way back in Chapter 2, we proved that if we have 2 pairs of supplementary angles that have one pair of them congruent to each other, that means the other pair has to be congruent. We already know 3 and 4 are the same. That means 1 and 2 must be the same. Angle 1 is congruent to angle 2. That was our congruent supplements theorem. If you don't remember the congruent supplements theorem, it's just really one extra step. Instead of calling them supplementary angles, we would call them a linear pair. We would say angle 1 plus angle 3 equals 180, angle 2 plus angle 4 equals 180. And since they both equal 180, they equal each other, and then we can subtract out equal angles. But if you can remember your congruent supplements theorem, it just saves you one extra step. Not a big deal if you don't remember that. So that's another possibility. We could be asking for angles congruent, but if they're outside the figure, then it's not going to be the exact same concept. Alright, so now we're given this figure right here. We're given circle A, so A is the center. We want to prove that BC and ED are parallel. Again, let's ignore that for a second. Let's prove the 2 triangles are congruent first. So we have our givens. I'll actually just write circle A because that's easier than writing givens this time. Now, if we have a circle, that means that all the sides right here, AB, AC, AD, AE, anywhere that goes from the center to the edge of the circle, are all radii, and therefore congruent. So AB is congruent to AC, which is congruent to AD, which is congruent to AE. Radii of a circle are congruent. We also have our 2 vertical angles, angles 1 and 2. They are congruent. And now, I have enough information to say that 2 triangles are. We can say triangle ABC is congruent to triangle ADE because of side, angle, side. 2 sides equal, the angle in between. So again, we want to prove triangles congruent first. Now, we want to prove 2 lines are parallel. So in the previous chapter, we talked about proving lines are parallel. If I could find corresponding angles equal, lines are parallel. I don't have any F's here, so that's not going to work. If I could find alternate interior angles congruent, then lines are parallel. And what do you know? I have a Z right here, where angles 3 and 4 are both my alternate interior angles. So 3 and 4 are both congruent, not because they're alternate interior, because I haven't said anything about parallel lines yet, because they are corresponding parts of the congruent triangles. Because they're now equal, and they happen to be alternate interior angles, that means that BC is parallel to ED. And that's called our alternate interior angles converse. Whenever we're trying to prove the 2 lines are parallel, you have to use one of those converse theorems. Typically, it will either be your alternate interior angles or your corresponding angles. Depends on whether you have an F or a Z in the problem. So again, first prove you have triangles congruent, and then look at your proof statement. See what you need to do to get that to be true. If I want parallel lines, I need alternate interior angles equal. So those are both corresponding, that's why I say that, and therefore my lines are parallel. Okay, one more proof. So we were given this triangle right here. We're told that SQ bisects angle RST. We're also told that SQ is an altitude. We'll review what an altitude is. We want to prove that it's also a median. And again, we'll talk about what that is in a second. So we have our given statement. So if SQ bisects angle RST, that means it splits into 2 equal angles. So angle 1 is congruent to angle 2. This is your definition of an angle bisector. If SQ is an altitude, what an altitude is, it's a line that goes from the vertex of the triangle to the opposite side and is perpendicular. So that means angles 3 and 4 are right angles. That would be a definition of an altitude. Again, the altitude is just a perpendicular line that happens to go from the vertex of the triangle to the opposite side. Now, with our right triangles, since that's what these two are, I either need to look at HL or I need to find some other information. Now, I do have my right angles, however, I do not have my hypotenuse. Therefore, I can't use HL because I don't know anything about SR and RT and ST, and I can't prove anything about them. So instead, I need to say angle 3 and 4 are congruent. Because right angles are congruent. You don't need to say this if we knew something about the altitudes, but since we don't, we can't say that. We also need to have a side, and well, that's our reflexive side. SQ is congruent to itself. We have our reflexive side. So now I can say my triangles RSQ is congruent to triangle TSQ because of I have two angles and the side in between, so that's angle, side, angle. So this whole process to first prove we have a congruent triangle pair. Now, I want to prove SQ is a median. What a median is, it's the line that connects the vertex of a triangle to the midpoint of the opposite side. So I need to prove that Q is a midpoint. If Q is a midpoint, that means RQ and QT are both the same, and since they're corresponding parts, I can say that. I can say that RQ is congruent to QT because they are corresponding parts of congruent triangles. Since we now essentially have a midpoint, that means SQ is a median. Why? Definition of a median. So there's that proof. Again, this one's a little bit longer, and you'll find generally the proofs that have to go beyond corresponding parts will generally be much longer proofs. Triangle congruence can go anywhere really from 3 to 6 steps for the most parts, so I can add on at least 2 more steps if I'm going beyond corresponding parts. But again, the key is first show the triangles are congruent. At least do that. If you totally blank on how to go further from there, you won't receive obviously full credit on your proofs, but you'll at least receive most of the credits. And from there, you just take a look at that proof and figure out, okay, what do they want? If this was true, what would I need? That's how we know to go with our corresponding parts to then say what we need to say. Alright, so that's it for our congruent triangles, so study hard, and I will see you next time.